All right, so for this guy, we need to find the general solution to the differential equation dy dx equals 3x squared over y. This is what we need to do. We need to crisscross applesauce, like so, and say that we have 3x squared dx, leave a little bit of space, y dy. Now let's integrate both sides with respect to their specific variable. So if I integrate 3x squared dx, I get x cubed, how nice, plus some arbitrary c. That's going to equal the integral of y dy, which is going to be 1/2 y squared plus some arbitrary c. Now, these c's don't really matter, so choose one, get rid of the other, so adios. What I need to do now is I need to solve for c, which I shouldn't have done that because I should have just kept that c over there. Stupid me, doesn't really matter. Minus c gives us x cubed minus c equals 1/2 y squared. Okay, to solve for y, we need to multiply both sides by 2. Okay, so multiplying both sides by 2, and let me kill two birds with one stone here, okay? The right side just becomes y squared, easy peasy. If I multiply 2 to x cubed, 2x cubed, we know that. 2 times negative c changes nothing. In fact, I'm going to keep it as positive c because it's just some arbitrary constant anyway. It doesn't really matter what it ends up being. Now I need to square root everything, and when I square root both sides, I can't forget the positive or the negative, and so let's just flip this over and have y equals positive or negative square root of 2x cubed plus c. And that's going to be my guy. Fun stuff. Find the general solution of the differential equation dy dx equals y plus 5 in parentheses times x plus 2 in parentheses. So this is what we need to do. We need to separate the variables with their respective dy dx. Okay, so if I were to multiply both sides by dx, and while I'm at it, divide both sides by y plus 5, this is going to look sloppy, but bear with me. Okay, that cancels out, that cancels out. And what I'm left with on the left side is 1 over y plus 5 dy is equal to x plus 2 dx. Now, in order to make those dy's and dx's go away, we have to integrate both sides with their respective y and x values. Okay, so the left side is going to require u substitution. So let's let u equal y plus 5. Du dx, or du dy, I guess in this case, would equal 1. How nice. And so multiplying both sides is going to give us du equals dy. So continuing this guy over here, we get the integral of 1 over u du, which ends up being ln of x plus c, not ln of x, ln of u plus c, and since u was y plus 5, we have ln of y plus 5 plus c. Gross, 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 gross. Now over here is very friendly. The right side, very friendly. Okay, the integral of x is 1/2 x squared. The integral of 2 is 2x plus some arbitrary c again. Okay, so let's bring all that down, and we're left with this. Now I have to get y all by itself. This is going to be disgusting. So what I can do is, I don't need both of these plus c's, so let's get rid of that plus c on the left. And so that leaves me with ln of y plus 5 equals 1/2 x squared plus 2 plus c. In order to get rid of that ln and isolate the y, I'm going to have to e to the both sides. Now I know that's not proper, but if I e to the both sides, what that does is it allows these to cancel out and it drops down y plus 5. Now the right side is e to this whole thing, 1/2 x squared plus 2 plus c. But wrapping this problem up, we subtract 5 from both sides, and my final answer is going to be y equals e to the 1/2 x squared plus 2 plus c minus 5. Pretty? No. Correct? I hope so, otherwise I'm wasting my time. Find the general solution of the differential equation y prime equals y cos x. Now, I'm going to turn y prime into dy dx. Looks better. Y cos x. I'm going to multiply both sides by dx and divide both sides by y at the same exact time to separate the variables. So if I multiply both sides by dx, the right side becomes cosine x dx. And if I divide y from both sides, I get 1 over y dy. Now what I do is I integrate both sides with respect to their variables. Integrating 1 over y dy is ln of y plus some arbitrary c. Integrating cosine x is going to be regular sine x plus some arbitrary c. Now I only need one of these c's, and so since I want to get y all by itself, let's just get rid of the c on the left side, don't need it. And in order for me to get y isolated, I need to take the e to the of both sides. What that does is that allows the e and the ln to cancel out, leaving me with just a y down here. And on the right side, I'm end up with e to the sine x plus c. And that's my guy.